Question over here.
It's a good place to be talking about this, given that we're at Fred Hutch.
Yeah,
There's
right.
a lot of cancer biologists in the audience.
My name's John. I work for Evergreen Wellness Advocates, and I happen to be one of the millions of people who are directly benefiting from your work. I'm profoundly grateful, and it's a privilege to be able to meet you and talk to you. My question is, it seems to be that the strategy, and your slides are educating me as I listen.
We don't even know what's
the strategy for gene therapy is to knock out the Ccr5
That's
receptor.
one strategy.
Right. So what is that Ccr5 there for to begin with, and what are the consequences of losing it?
Absolutely. It does have a day job. So one of the things I've learned is, we have all these genes in our body, and some of them are super important and you can't do without them, and some of them are not as important, and some of them are probably redundant. So I think with the case of Ccr5, it actually does have an important job. One of the things it does is it helps some of our immune cells get into the gut, which is a really important place for them to be. They're kind of patrolling, making sure that no bacteria and no food kind of get from the gut into the body. So it sounds like Ccr5 should be indispensable, but it isn't, and nature sort of showed us that, because about 1% of people don't have Ccr5 and they don't fall down dead, or at least they don't fall down with a really bad case of diarrhea, okay? So, I think as scientists, one of the places we will always look is we'll say, what can nature teach us? So when people first discovered the importance of Ccr5 for HIV, it was as a result of studying people who were surprisingly resistant to HIV. Being Ccr5 negative is not exactly the same as having Ccr5. There's some subtle differences, but really nothing that would have that we would have sort of, I guess, guessed if we hadn't known about the fact that 1% of people don't have it. One of the things that's quite interesting is why do so many people not have Ccr5?
Nobody knows.
They don't, but scientists speculate. So there were two sort of big theories. Do you guys know? What do you think? It is a certain geography, yeah.
So can we do this? Can we explain really quickly Ccr5, kind of its relationship with the cell, as well as its relationship with HIV? Like, why is Ccr5 important to HIV? Just so folks have a context for the conversation.
Right.
I'd say it's a gateway and doorway that what's a receptor for HIV, but can you just kind of give a little context?
So Ccr5 looks like this. It kind of looks like the Loch Ness Monster, and it sits on the surface of certain white blood cells, including the white blood cells, the CD4 T cells that HIV infects. And we call them CD4 T cells, and the CD4 part is really important because when HIV infects a cell, it does it because it first of all binds to CD4. It's whizzing around your body, it's kind of ignoring your liver, it's ignoring your lung, but it gets to a CD4 T cell and it goes, ooh, I kind of like that one. So it binds to the CD4, but that in itself is not enough. HIV also has to then bind to a Ccr5 molecule also on the cell surface. And it's only when it's docked onto both of these molecules that it then kind of opens the door and the virus can get into your cell. So a perfectly HIV-resistant person would actually be somebody who didn't have CD4. Can you imagine? That'd be awesome. Unfortunately, CD4 is pretty important.
Immune system.
Yeah, you wouldn't have an immune system. So
the mice.
Yeah. So doing anything to CD4 is not going to work as a strategy to stop HIV. But Ccr5 really is one of the Achilles heels of this virus, because if you don't have Ccr5 on your cells, like 1% of people, HIV really can't get in. So, as soon as scientists kind of understood this, it really gave gene therapists like David and myself this idea that, okay, well, we could go in and we can take Ccr5 out of cells. We can take cells out of people. We can take out the Ccr5 gene, kind of like an eraser, and we can pop it back in. And in that way, we're giving them their own cells back that are kind of like an improved version that's now resistant to HIV. And this really is the basis of some of the earliest types of gene therapy that are now, in the clinic.
So Paul and I are doing this today differently. She's doing it with people who are actually cutting out genes from a cell, and you can cut out the CCR5 gene. And the cell seems, to a first approximation, perfectly normal. You can also stop the function of CCR5 by using what's called a small interfering RNA, and that's what we've been doing. And you can put that in using a gene therapy vector.
You have to take it out first.
We actually do it through the stem cells, the hematopoietic stem cells. We take out the stem cells, modify them so that they make this siRNA and put them back. And that's now being in clinical testing by a company represented by two gentlemen sitting up here, the two Jeffs, called Calimune. And Calimune has now probably a year and a half of clinical experience with this. And we know it's safe, and we know it's complicated. And we can't say anything more than that at this point.